Today, we will present our assessment tool for the course Further Calculus for Engineers MAT 455. Our presentation focused on three-dimensional solids and their projections on the x-axis, y-axis, and z-axis. We will explain task 1, 2, and task 3. For task 1, the question states the given solid A bounded by the surface x equal to y power of 2, plane z equals to 1 minus x, and z equals to 0 and y equals to 0, as shown in the figure below. For question A, we have to draw the solid A using mathematical applications such as GeoGebra and etc. So we have done the solid A figure by using Desmos, and this is our figure. For question B, we have to draw the projection from x-axis, y-axis, and z-axis. For z-axis, we just have to look at from x-axis, and this is from y-axis, and lastly, this is from z-axis. And for question C, we have to find the volume of integral from each projection, from x-axis, y-axis, and z-axis. This is our calculation for question 1C. And first, for the calculation, we have to set up the integral based on the question given. The integral that we have to set up is just dx, dy, and dz, and we have to find the limits. And from x-axis, the limit for dx is y power of 2 until 1 minus z. For dz, the limit is from 0 until 1 minus y power of 2. And for dy, the limit is from 0 until 1. And after we find the limits and the integral, just do the calculation and until you get the final answer. And the final answer for x-axis is 4/15. For question 2, we have to find from y-axis. Same as before, we have to set up the integral dy, dz, and dx. And from dy, we have to find the limit from 0 until x square root. And for dz, we have find the limit from 0 until 1 minus x. And dx, we find the limits from 0 until 1. And just do the calculation until we get the final answer 4/15. For z-axis, same as before, we have to set up the integral dz, dx, and dy. For dz, the limit is from 0 until 1 minus x. For dx, the limit is y power of 2 until 1. And for dy is 0 until 1. And just do the calculation until we get the final answer. And the answer is 4/15 too. Next, for question 2. Question 2 is we have to draw the solid E by using the equation given. For cylinder, y power of 2 plus z power of 2 equals to 4. The plane z plus 2x equals to 6, and the cone 2x equals to square root y power of 2 plus z power of 2. By using Desmos, this is our figure for solid E. And for the projection, this is projection from x-axis, as you can see here. This is from y-axis, and lastly this is from z-axis. And for question C, we have to evaluate the integral square root y power of 2 plus z power of 2 dv by using appropriate coordinate system. As the question given, the square root y power of 2 plus z power of 2 is cylinder, so we have to find the appropriate coordinate from the x-axis, since it is part of the cylinder. And for the calculation, this is our calculation. First, we have to find the radius, and by using the formula square root y power of 2 plus z power of 2 equals to r. Since the question have given y power of 2 plus z power of 2 is equal to 4, then we will just assume that 4 is equals to r to the power of 2, and the r we will get 2. So the limit for radius we will get from 0 until 2. Next, we have to find the angle. For the angle, since this cylinder is a perfect circle, so the angle should be from 0 degree until 360 degree, or in pi we will state it as 0 until 2 pi. And last but not least, we also have to find the limit for x. For x, we have find the limit from two surface. First, from plane, z plus 2x equals to 6, and the final answer is x equals to 3 minus r sine theta over 2. And from cone, we use 2x minus 2x equals to square root y power of 2 plus z power of 2, and we get the s equals to r over 2. So the limit for x is r over 2 until 3 minus r sine theta over 2. Next, we have to set up the integral. Since we have given by the question, the integral is square root y power of 2 plus z power of 2 dv. We have to change this boundary into the r times r dx, dr, and d theta. And for the limit, we just insert the limit that we have calculated before. For dx, from r over 2 until 3 minus r sine theta over 2. For dr, we got 0 until 2, and d theta we got 0 until 2 pi. And just calculate the integral given until we get the final answer, 12 pi.
Now we move to the final task, which is task 3. For task 3, we are given solid Q. The solid has different shape compared to solid A and solid E. Visualizing the solid is important to avoid mistake in defining the region of integration. So this is the shape of solid Q. After we insert all of this equation, for question B, draw the projection of solid using mathematical application using the algebra of Desmos. So this is the view from projection X, view from projection Y, and finally view from projection Z. And lastly, evaluate the equation triple integral Q using appropriate coordinate system. Step 1, choose the order of the integration. Based on the projection, we choose the order of integration as dv equal to dz, dy, and ds. This order is chosen because it makes the limits clearer and simpler. Step 2, set up the integral. The triple integral is set up as this integral represents the volume of the solid. The lower and upper limit for integral are taken directly from the projection diagram. And step 3, we integrate step by step. First, we integrate for the x, then we integrate for y, and finally we integrate for z. Each integral is done step by step until a single numerical value is obtained. And finally, we will get the final answer, which is right here. The final result represents the volume of the solid for question C. All calculations are shown clearly in the report, and graphs are used to support the integration limit. So that's all from us. Thank you so much.